Hi, all. In the session number 6, we are going to see about the hot potato routing. Suppose there are two or more best inter routes, then which routes to choose with the closest next hub? First, we use the OSPF to determine the which gateway is closest. The question is from 1C, choose AS3, AS1, 31 or AS2, AS17. The answer is the route AS3, AS201 since it is closer. Summary, the routers become aware of the prefix. How it is possible is to via BJP route advertisements from the other routes. So second one is the determine the router output port for prefix. Use BGP route selection to find the best inter-AS route. Use OSPF to find the best intra-AS route leading to the best inter-AS route. Router identify the router ports that are the best route. We can see here the BJP routing policy. So here you can observe node A, B, C are provider networks. X, Y, W are the customer of the provider networks. The X is the dual owned, means the X is connected or provided by both the network B and C, which are attached to B and C. Suppose X does not want to route from B via X to C. So the X will not advertise to B a route to C. The second, the A advertises, the second policy of BJP is the A advertises a path AW to B. The B advertises the path BAW to X. Should B advertise the path BAW to C? So no, the B gets no revenue for routing CBAW since neither W nor C are the B's customer. So B wants to force C to use the routes to W via A. So B wants to route only to or from its customer. So in inter-AS, the admin wants to control over how its traffic routed, who routes through its net, and in intra-AS, a single admin, so no policy decision is needed. So hierarchical routing saves the table size, reduced update the traffic, so it is used the scalability. So intra-AS can focus on the performance. So then we'll see about the broadcast and multicast routing. The broadcast routing delivers a packet from source to all other nodes. The source duplication is inefficient. So source duplication, so how does the source determine the recipient the address? You can see here the router R3 and R1 find the duplicate recipient addresses. In network duplication, the flooding when the nodes receive broadcast packet which sends the copy to all the neighbors. The problem is the cycles and broadcast room. The controlled flooding, the node only broadcast the packet if it hasn't broadcast the same packet before. The nodes keep track of the packets IDs already broadcasted or the reverse path forwarding RPF, the only forward packets if it is arrived on the shortest path between the node and the source. So you can see the spanning tree over here. The first construct a spanning tree. Nodes then forward or make the copies only along the spanning tree. Broadcast initiated at A. Here the broadcast initiated at D. So how do we create a spanning tree? Which create from the node, each node sends a unicast joining message to center node. The message forwarded until it arrives at a node which is already belongs to the spanning tree. You can see the direction how the spanning tree are created. In the multicast routing, the goal is to find a tree or trees connecting the routers having a local multicast group members. Not all paths between the routers are used. Shared tree, the same tree are used by all the group members. You can see the different color combinations of the systems where it shows which is a group member and which is a not group member, and a router with a group member and router without a group member. So it finishes the session number 6 videos. We'll see at the last session how the things are computed in the session number 7, the module 3.